In this problem, we're looking at titrations and finding one that has a pH point less than 7. We know that if we're dealing with a strong acid plus a strong base, the equivalence point is at pH equal to 7. If we have a strong acid and a weak base, our pH is less than 7. And if we have a weak acid plus a strong base, our pH is greater than 7. So in each of these species, we're going to consider this fact. The first one, we can see we've got a strong base and a weak acid. So we'd be expecting our pH to be greater than 7, which doesn't meet our criteria. The next one is a strong base and a strong acid, which we would expect the pH equal to 7, so that won't work. The next one is a strong base and a strong acid, so again, pH equals 7, so that's not going to work. The next one is a weak base and strong acid. Well, that pH should be less than 7. This one seems like a good choice. The final one, we have a weak acid and strong base, and that one should have a pH greater than 7. If we took a look at NH3 in water, it will produce NH4 plus and OH minus. The strong acid, the HCl, will separate completely to the hydrogen ions and the chloride ions, and this hydrogen ion will react with the hydroxide. That will be the neutralization. But that leaves us with the NH4 in water, which we know will produce NH3 and H3O plus, which is why at neutralization the equivalence point is less than 7. So our correct answer will be the ammonia and hydrochloric acid titration.